watching this video. My name is Olenjolai Mokota Single from beautiful, fantastic country, called the United Republic of Tanzania in eastern of the African continent. I would like to take this special moment to be with you, to welcome you into our online undergraduate Polytechnic Institute of Tanzania. And also simultaneously, I would like to take this special moment to get connected with you wirelessly, to welcome you into our official YouTube channel that's called the that's called the Online Undergrad Polyinstitute, Online Undergrad Polyinstitute of Tanzania, square bracket OLENJOLAIM. The complete names of the institutions is called the Online Undergraduate Polytechnic Institute of Tanzania. And then this in our official YouTube channel, you have to make this in square bracket. You find OLENJOLAIM. That is our unique official channel at this moment. Once we'll be having some other official channels, we'll let you know as we continue. So I would like just to remind you briefly, before even we start today's sessions, about the visions that is in my mind, in my heart, in my mind, in my subconscious mind, in my heart, in my soul, in my flesh, in my thinking. This is the vision that we have, and God has declared clearly in my heart, that I would like to prepare some students who will be ready to take engineering concepts that they are learning in the classroom, scientific concepts that have been learned during the school, secondary educations, and even they are learning at this moment in undergraduate level, combined with engineering also concept and knowledge that you've been learning from your first year until you reach the fourth year, or even you go for the postgraduate studies. You combine those knowledge, those skills, right? Those is set. I call it a set of skills that you've been achieving in every level of your study, with the spiritual knowledge of Word of God, knowledge and wisdoms of Word of God that is obtained from the a unique, fantastic, exceptional manuals that's called the Bible, in order to solve real life problems, either single problem or a real life problem. So our main objective in this online undergraduate Polytechnic Institute of Tanzania is this: we would like to see our students who are still doing who are still pursuing some different courses or different programs in engineering and science, okay, to solve, I mean that to know that they have a responsibility to solve at least a unique problem in the society. It's not a problem for the exams, it's a problem for the lifetimes, to save the community. It means that to solve a particular problems, maybe to increase the security of your place. It depends that which problems and which area of interest that you have, right? So that's our main objective. We have some few specific objectives. We have a many specific objective in these programs, or in Online Undergraduate Polytechnic Institute of Tanzania. But the first specific objective will be helping our students to pass all the continuous assessment and even the final exams, or we call it the university exams in some of the institutions or college or universities. That's one of our specific objectives. Second specific objective also, we like to see our students, they graduate successful, right? They graduate means that there's no absconding, no discontinuity, no retake, no postponements, as those other obstacles that will let you not to achieve your goals. So that's our second specific objective, to see our students, they graduate. But our third specific objective, we like to see our graduate students solving real life problems, right? Real life problems. And then, because at the fourth specific objective, like to see our undergraduate students, when you graduate, you'll be rewarded or awarded a certificate, which we will have a certificate for that level, for instance, that the undergraduate certificate, and also academic transcript. And then our fifth specific objective, we like to make sure that all our students love engineering and scientific mathematics for the rest of their life. Can I tell you another special? It is enough. Again, we have some departments in this online undergraduate polytechnic institute of Tanzania. But one of the departments is the huge departments that we call to is the largest departments at this moment, that's called Higher Engineering and Scientific Mathematics. In these departments we are teaching 12, it means that 12 modules or courses for undergraduate level. And one of the modules that we are teaching is this one that's called the differential equation and complex variable. But this for undergraduate, not for advanced level. This is for undergraduate. And these modules is taught in the first semester in many institutions or many colleges or many universities, depends on your university. But in the reference institutions that called the National Ministry of Technology, it means that we used to teach these modules in first semester of the second year. So regardless whether you learn differential equations or complex variables in first year, second year, first semester, second semester, don't worry. Focus on the contents. Differential equation, complex variable is a universal modules, or it's a universal course. Even if that you are studying in Massachusetts Institute of Technology, you will find some of the contents that I'm going to cover, because mathematics is universal, right? So, after giving you such kind of the brief introductions, I would like just to do the quick review and then take you into the today's session. We have so many, so we can group this. Remember that we said that we can group these modules. Mean that mean that this module or course, remember that, or course in some of the institutions can be classified into two branches, okay, into two branches, because of the difference in the concept that you are going to cover. The first branch, we call it differential equation. So this is the first branch that you are going to cover in this course, differential equation. And this one specifically, we won't touch any of the partial differential equation. We focus on ordinary differential equation, but special ordinary differential equations that we need something we call the power series solutions to solve them. Then the second branch is, we call it complex variables. So complex variables, very interesting modules, very interesting branch, because here we'll be focusing on complex function. Just to mention, complex function, we'll be focusing on differentiation, because you don't know differentiation, you know differentiations of real function, right? Differentiations of the complex function, and then integration of complex function. Those are the three main branches of this second branch. Let's now pay our attention onto differential equation. So differential equation, we say that, just to introduce or to give you the general overview, we say that, because this is general introduction, so differential equation. Okay, differential equation, I don't want to define it, we'll define it later on when we define it in the advanced calculus, so just refer the previous definition. So differential equations is an equation that containing what? So you should remember that. Okay, so I think that we should start from that point. So we have the first topic is series, but the main subject is differential equations. So let us begin with the general introductions. Yes, just okay. The first question: what is define differential equation? Define differential equation. Okay? Define differential equation. So so differential equation, because I'm building the foundation. Differential equation. And this foundation, the devil cannot break it. So we say that is an equation that containing a function depends on either single or multivariable, multiple variables, and they are derivatives. They are derivatives in respect to the single or multiple variable. Are the means of differential equation. Again, another piece of information which I want to remind you: differential equation, which we abbreviate as EQ. Okay, EQ is the one of the branch of calculus for the second year ordinary diploma students. And also have a special YouTube channel and even school that's called Tanzania Online A-Level Circuit School in square bracket OLENJOLAIM, where I used to teach differential equation for advanced differential equation for advanced students. So that's what we call it. Differential equations is the one of the branch of 40 of the calculus. Other branches are differentiation and integration. So that is the general concept that you have to bear in your mind. So, but we say that you have to not before. In this module, of course, we will solve differential. We solve ordinary differential equation. Ordinary differential. Okay, ordinary differential. This is the general introduction. Equation which contain variable, okay, or which contain variable, because which contain function in the function as they are the coefficient of their differential derivatives. Okay, derivatives. Okay, by using power series. Solution. So we will never differentiate in this module. We will never integrate. But we'll be solving differential equation not by integrating, not by using integrating factor, not by using exact method, not by using inspection, not by using Bernoulli's solutions. We'll be solving differential equations which actually are completely different from the differential equation that you know. We'll be solving them by using power series solution. Say again, power series solution. Even if you forget everything that I'm going to teach you in this session, but remember this in your mind, that Olenjolai is going to teach me power series solutions to solve ordinary differential equation which the coefficient of their differential derivatives are functions. They are not constants. I will explain to you possibly in lecture 6 or 7 or 8. I'll be explaining to you this point and give you example and give you distinctions of the differential equation that you know. Don't throw the concepts of the differential equation that you have learned in advanced level or in ordinary diploma level. Don't throw it away. You will need it to solve real life problems in engineering or in science. So we'll be focused on power theory solutions. So because we'll be focused on power theory solutions, that's why that we need to cover few concepts in the topic of series. Series is a branch of mathematics, or it's one of the branches of algebra Very interesting. We won't cover everything about series, but we'll be selecting few concepts which are useful on learning the power series solution. Right? So we say that this is another key point to understand the power series solution. Power series solution, right? Power series solution. Say that the student has to learn, okay, some basic concepts of series, okay, of series as the prerequisite of series, as prerequisite of of power series solution. So that's why that I say the first topic I want to teach you about series, but I'm not teaching algebra, I'm teaching differential question. Later on, I will be teaching about complex variables. It's very complex. One, I like differential questions that I'll be teaching you. I like it so much. And I like complex variables that I'll be teaching in this module. And I'll try my level best to convince you to love it, even to do excellently more than I did myself. Okay? And even teaching some other students. So, you can refer also, the prerequisite of these concepts is about series. It's just a series, just know you need a few concepts of the series. We won't spend much time on defining what the meaning of the series, okay? But we'll be just taking a series. So in case you need to know the definition of the series, you have to refer one of my official YouTube channel that called Tanzania Online O-Level Circuit School, so that in square bracket OLENJOLAIM, I spend almost more than 50 minutes to explain the meanings of the series. So you have to check it, to watch that video, and then you continue with this concept. So what are the concepts that we want to cover in series, right? So the first concept, you have to learn about the sigma notation. So we can say that general introductions of 40 sigma notations of series, okay? Sigma notation. That's the general concept. And then I would like to ask you a few questions. This is the first question. First of all, this is the combination of the two words. What is the meaning of sigma? What does the word sigma mean? Okay? What means of the word sigma? Right? What is the meaning of the word sigma? So sigma is the 18th. Okay? So this is the 18th Greek letter, 18th letter of the Greek. Greek, it's a name, alphabet. So the Greek language, it has its alphabet. Okay, alphabet. Okay, so then that we say that we have uppercase and the lowercase. So before even we say that the uppercase of sigma in Greek is this, at the uppercase, right? It's the summation sign. Then the lowercase of sigma is this. It's the symbol for the standard deviation. So we say that sigma is translated in English or is equivalent to letter S in English. Letter S in English. Remember that our point of focus is sigma notation, because sigma notations is used also to prevent the terms that we call it algebra or series. So I asked myself the second question: what defines the sigma operator? I know that you won't be ask me this question in exam, but you have to understand that sigma operator we say that sigma operator is there uppercase, is the uppercase of sigma, which is this, okay? Use the as an operator of summation. Use as an operator of 40 of summation. So that the meanings of 40 of sigma operator. And the lowercase, this is additional concept. The lowercase of sigma, which is this symbol, is used to notate what? Standard deviation. Standard deviation and variance, if you square it. Standard deviation. Okay? So that's the lowercase and that's the uppercase. Now, if that's the case now, I ask myself the third question. What is the meaning? What is sigma notation? Because today's concept, I told you that I'm going to teach you the general introduction of sigma notations of series. What does it mean? I found very interesting definition. Sigma notation, which is the uppercase, is a convenient and simple form. Is a convenient and a simple form convenient and simple form, of shorthand. Used it to give a concise expression. Concise expression for a sum of values values of variables. So sigma notation is the convenient and simple form of shorthand. So if you want to write either finite or infinite series that we taught you in O-level or in ordinary secondary education or in ordinary diploma or in advanced mathematics, then you may use the sigma notation. So we say that it's a convenient and simple form of shorthand used to give concise expressions for a sum of values of what? Of variables. You might find alternative definitions of sigma notation, but on my side, I found that this is the best because it's really explaining that sigma notation is what? This is the simple shorthand, right? Used it to give what? Concise expressions for what? For the sum. So sum of the terms, sum of the values of the variables, etc., etc., are the meaning of what? Of sigma notation. Okay? The sigma notation is given as this one. This is a sigma notation, right? So that's the symbol for the sigma notation. With this symbol of sigma notation, we can have variables in 4 parts. And have a variable here outside of the sigma notation. We can also have we call the initial counting index. You can also have final or the last counting index, which should be kind of the variable there. You can also have the coefficient and even the expressions of the series. So you have those 4 parts. So V, remember that if V1, which is equal to V2, which is equal to, means V as V, this I just took notation of what? Of variable. That representing a certain value. So that is the symbol for the sigma notation in mathematics. So in having variables at this place or at this point or even here, we have to follow some special rules. We should follow the guidance. So now let me take you into the part that we call mathematics, index or subscript notation. Index or subscript notation. Index or subscript notation. The algebraic symbol xi. This is pronounced as x subscript as variable x with the subscript of what? Subscript of I. Sub stands for subdivisions of subscript. So if you have x, then you have I in subscript, then we define it as what? As variable x subscript of I. Okay? That's a very important point. So what does it mean? So x represents what? For that expression, x represents variable, okay? While I represents the subscript. Let me write clear. xi. X represents variable and I represent subscript. But in some other cases also, we can have superscript, especially inside the sigma notation. So J stands for the superscript. Again, we say that both, this you have to note, both subscript and superscript are positive or should be positive integers. So here we just introduce only integers. We cannot introduce fractions because we can things by using integers. Integers from what? Between 0 and n. So what does it mean? For instance, that we find I might be 0 or 1 or 2 or 3 or 4 or 5 or 6. We find J is equal to 7 or 8 or 9 or 10 or 11, etc. So then again we have a variable we're still in that part of 40 of index or subscript notations or superscript notation. We say that any of this, or this the general comments also, any of these letters can be used to represent a subscript or index. A subscript or index of sigma notation. The subscript is commonly more than even summation because we are talking outside this point and this point, or index of sigma notation. What are the letters? So these are the letters which are useful, right? The first letters, these are J, K, I, L, M, N, R. So those are the how many letters? 7 letters that are used to indicate subscript or index of the sigma notation. So you have to bear that piece of information in your mind. Often avoid letters that are known, say, to represent constants or real or complex variables such as A, B, C, or X, Y, Z, or letters that have special meanings or values such as E and G. So that's another point that we can define, or we can speak about. Okay, mathematically, how do we counter sigma, right? So mathematically, for instance, you're being given. So we say that these are the letters that are used at the index of the sigma notation, J, K, I, L, M, N, R. So for instance, we'll be given this series, which is x1 plus x2 plus x3 plus x4 plus x5 plus x6 plus dash 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 to plus xm. And how do you write in sigma notation? Right? First of all, we have to let the subscript, which is 1, 2, 3, and 4, and 5 and 6 to be like natural numbers. Right? So if that's the case, then we say that for this case, that expression, which is x1 plus x2 plus x3 plus x4 plus x5 plus dash 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 plus xm. This one, or xi, let's say. Okay? So that's the sigma notation. And then we say that from x subscript of I. The first counting index, we say that I is equal to 1. And the last counting index, if you know, then you write. If you don't know, then you leave or you write just to infinity. Okay, so when we have these sigma notations also, when we want to use the sigma notation, we should know the type of the series first. So that's why that I would like to teach you about the types of series right now. Our point of focus is sigma notation, types of series. So in mathematics, there are two types of series. There are two main types of series. So these are the two main types of series that are finite series and then set of infinite. So there are two types of series that are finite series and infinite series. So let me touch, because we'll be focusing more on the infinite series. Let us have a look at finite. Okay, so we say that what is finite series? A finite series is the summation of the finite number of terms. Simple. A finite series is the summation of finite terms. So you can define the infinite series. So this finite, it includes first term, middle terms, and the last term. So when you write the finite series, you should have that picture or that concept in mind. Finite series include the first term, middle terms, and the last term. Right? So, example. I'll give you two examples of finite series. The first example of finite series, we call it what? So the first example is in case that we have possibly 4 plus 6 plus 8 plus 10 plus 12. This is the finite series. Also, you can have finite series of letters. x1 plus x2 plus x3 plus x4 plus x5 plus x6, for instance. This is the finite series. Again, you can have a finite series in rational. You can have that a1 over b1 plus a2 over b2 plus a3 over b3 plus a4 over b4 plus a6, a5 plus over b5. So these are, in case you write a finite series in long terms, not in shorthand. So by using sigma notation, for instance, you can write this series as what? So you can say that summation, right? So let's say that these numbers, we call them the nth term is n, or is twice n, right? It's twice n, let's say. So when n is equal to what? Begins from 1. And the last term, so when n is equal to 1, 2 times 1 begins with 2. So 2 times 2 for excuse me. So for instance, the nth term for this case, it is n plus 2. So the first term, n is equal to 1. N is equal to 1 or n is equal to 2. N is equal to 1. So for this case, because the first term, simply say that the nth term is equal to what? First term is 4, then n minus 1, common difference is 2. So this is makes 2n plus 2. So the nth term for that series, for that sequence, is 2n plus 2. So when n is equal to 1, 4. N is equal to 2, 6. N is equal to 3, 8. So this n is equal to 4, 10. N is equal to 5, so until to 5. So this is the shorthand. I know that, I'm just reminding. So here we have a variable x, subscript of I. So when I is equal to 1, the first term, and the last term when I is equal to 6. So the third expressions you can write also in sigma notation as this. We have ai over bi when I begins from 1 to 5. So all of these are examples of 40 examples of finite series. And we have used the shorthand of 40 for summation series. In these modules, we won't deal with finite series, we'll be focusing on infinite series. So ladies and gentlemen, let me teach you now about infinite series and till be the end of this session. Say infinite series. Very interesting series in differential equation. Right? Do you love it? Tell me in the comment sections if you do. So we have a fundamental question that what is infinite? We have been looking for infinite series. We've been looking for what is infinite series. We've been looking for it. So we say that infinite series, we say that is a series that is a series That's formed by summation. No, it's a summation, not a series. Or the type of series is a summation. So it's a summation of what? So it's a summation of infinite number of terms, infinite number of terms, and the last term, or the last terms, we call it the last terms, or how they define finite terms, and the upper limit of the is infinite. The last index. Let me use this. However, that I know you don't know what the last index. The last index of the series is infinite. Is what? Infinite. So that's the definitions of the term infinite series. So we say that is a summation. So infinite series is a summation of infinite number of terms. So we'll be having first term, second term, third term, fourth term, etc. Right? And the last term. And the last index of this series is what? Infinite. Right? It's infinite. So it means that we extract it to information. First of all, infinite number of terms, it means that you cannot count. So simply say that this infinite series, it includes, so it includes what? It includes the first term, the middle term, without the last term. So we don't have last term in infinite series. So in the next session or in the next lecture too, I will teach you in details about index. We have two types of index in mathematics. We have a counting index and summation index. And then in counting index, we have two types of index. Initial or the first counting index and the last counting index. So that's why we say that the last indexing or the last counting index is of the series is infinite, right? So let's see, let me give you some examples. Right? Some examples. So some examples can have few examples. For instance, that I have a series of 1 plus 2 plus 3 plus 4 plus dash 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 plus infinity. Okay? Also you can have another series, let's say of letters, that we say we have A1 plus A2 plus A3 plus dash 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 plus infinity. So those are the infinite series. But our point of focus is what? In sigma notation. So this infinite series. So infinite series notation. So this is notated by using sigma notation like this. Here we have first counting index, that I is equal to something, and the last counting index is infinite, and here we used to have something called the instant of the series. So this is infinite, or notation of infinite series. So for instance, this 1 plus 2 plus 3 plus 4 plus dash 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 plus infinity, in sigma notation we say that this is from n is equal to 1 up to infinity, and then you have n. Right? So this is the third example. The first example, we say that you can write this one in sigma notation. A1 plus A2 plus A3 plus A4 plus dash 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 plus infinity. This is equal to the shorthand of AI when I is equal to 1 to infinity. So this is the elastic counting index. So this is the very interesting expressions in what in differential equation. Okay? So in differential equation, or the power series method employs infinite series. So this is the point that I have to make. The power series method employs the infinite series in sigma notation to solve what? To solve ordinary differential equations. Ordinary differential equation. Okay? So because I didn't teach you about indexing, the first count index or whatever, I will be giving you the general format of how we write this infinite series in differential equations in the second session, which is the lecture 2 of general introductions of this of index. Now I'll be teaching you now about the index, shifting the index and whatever and so forth. Okay, so this is the very important concept right now. So mean that, let me leave the homework for you. This is homework 1. You have to make sure that you do. I have just a few questions. Okay, question 1. What is index? What is index? Right? What is index? And then the second question, question 2, with aid of examples, okay, with aid of examples, explain briefly the 2 types of indices in maths. So those are very simple questions for the senior students can go through them. This is the end of lecture 1 of the general introductions of the series. We are still in this topic, but in the next sessions I would like to invite you in the next lecture, lecture 2, when I'll be teaching about index, the very important components of learning infinite series and even power series solutions that we'll be using to solve differential equation. So I thank God who have been with me in the preparations of this session, of this lecture, sessions or periods of lecture. I use those words interchangeably. And I thank God who have been with me or who have helped me to teach these contents effectively in simple, simplified language and a very effective way of learning. And I thank God who have given you a chance to be with me in this first session. I still insist on you to watch lecture 00, the general introductions of 40 of engineering and the scientific mathematics, where I have introduced these modules. The general introductions of differential equations. Watch the video that labeled as lecture 00, the general introductions of differential equation and complex variables, right? So you have to enjoy the contents. I invite you in the next sessions. Make sure that you subscribe onto our official YouTube channel. Make sure that you read the descriptions below for this video. Make sure that you ask the questions in the comment section. Make sure that you tell us you enjoy this material in which institutions, in which regions, in which city, in which country, in which continents, in the comment section. So let us see the feedback that this material helps millions of the present and future generations. Share these contents with your colleagues, with your classmates, with other students who are in different universities, because there is no boundaries for this knowledge. It's a time for the knowledge of engineering and scientific